Today we will discuss experiment number 11, identification test for ferrous sulfate. To perform the identification test for ferrous sulfate, then objective of this experiment to understand the reaction involved in the identification test for ferrous sulfate, then to understand the use of reagents and chemicals in the identification test for ferrous sulfate, and then identify cation and anion present in given inorganic sample by performing various identification tests, and to perform and report the result and conclusion of the identification test for ferrous sulfate. Then chemicals: dilute sulfuric acid, 110 phenanthrone, ceric ammonium sulfate, potassium ferricyanide solution, dilute hydrochloric acid, potassium ferrocyanide solution, then barium chloride solution, iodine solution, stannous chloride solution, lead acetate solution, sodium hydroxide solution, and distilled water used for this identification test of ferrous sulfate. Then ferrous sulfate is having not less than 98% and not more than 103.3% of the ferrous sulfate with the water. Then ferrous sulfate occurs as a crystalline bluish green powder having astringent taste. It has a tendency to rapidly oxidize on exposure to moist air. It is odorless and is characterized through its metallic taste. It is stable in water but insoluble in alcohol, and it is used as an important hematite agent, that is for promoting formation of the hemoglobin in anemia, which is caused due to the iron deficiency, and in number of iron formulation, and in anemias excessive use or consumption mistakenly by children may cause the gastrointestinal irritation shock. Then orally it is administered in the form of tablet or capsule. In order to stabilize the ferrous form, certain reducing agents such as hypofluorous acid and dextrose are included in such formulation. Ferrous sulfate solution may bring about the discoloration of teeth in contact, and it also used in dyeing, tanning, ink industry, photography, and disinfectant. Ferrous sulfate, when heated, decomposes to yield ferric oxide, sulfur dioxide, and sulfuric acid. Ferrous sulfate reduces the salt of silver and gold to their corresponding metals, with some alkali sulfates forms double salts, and in the presence of light, ferrous sulfate reduces the mercury chloride to mercurous chloride. This is the reaction, and the identification reaction of the ferrous sulfates are summarized below. When ferrous sulfate reacts with the sodium carbonate solution, then carbon dioxide is evolved. Then next is a identification test for ferrous sulfate. This is the identification test for ferrous. Dissolve a quantity of substance under examination containing about 10 mg of iron in 2 ml of water, or use 2 ml of a prescribed solution. Add 2 ml of dilute sulfuric acid, then 1 ml of a 0.1% solution of a 110 phenanthrene. This observation is an intense red color is produced, and ferrous may be present. Then add ceric ammonium sulfate to the test solution number 1, and there is a red color is a discharge, and ferrous is a confirm. Then 1 ml of the solution containing not less than 1 milligram of iron, or 1 ml of the prescribed solution, and add 1 ml of the potassium ferricyanide solution. Then dark blue precipitate is formed. Then ferrous is a confirm. Then next test of this identification test for ferrous is add dilute hydrochloric acid to the test solution number 3. There is a uh, precipitate is insoluble and ferrous is a confirmed, then 1 ml of this solution containing not less than 1 milligram of iron or 1 ml of the prescribed solution, add 1 ml of the potassium ferrocyanide solution. There is a white precipitate is a form and rapidly becomes blue because of atmospheric oxidation, and there is a ferrous may be present. The next test of this, add dilute hydrochloric acid to the test number 5, then precipitate is insoluble and ferrous is a confirmed. These all tests used for the identification test of ferrous. Then identification test for sulfate, dissolve about 50 mg of the substance under examination in a 5 ml of water or use 5 ml of the prescribed solution. Then add 1 ml of the dilute hydrochloric acid and add 1 ml of the barium chloride solution. There is a white precipitate formation and sulfur may be present. And add 0.1 ml of the iodine solution to the suspension obtained in test solution number 1. The suspension remains yellow and sulfate may be present. Then add dropwise stannous chloride solution in the above solution, that is the test solution number 2. There is a discoloration and sulfate is confirmed. Then dissolve about 50 mg of the substance under examination in 5 ml of water or use 5 ml of the prescribed solution. Then add 2 ml of the lead acetate solution. There is a white precipitate is a form and sulfate may be present. Then add ammonium acetate solution with a sodium hydroxide solution to the test number 4. Then precipitate dissolves and sulfate is a confirmed. These all test identification test for sulfate and ferrous, the observation and inference is put into this result.